I'm creating this video in response to a thread and conversation I got involved in on Unreal Engine for Beginners on Facebook group. And let me explain what's going on here. So basically I've got a post-process volume in the world, which is just grey at the moment, but it could be anything, of course. And I have got a single actor item template, which I'll go into this in a moment, got a static mesh, which is being updated by an exposed mesh variable in our world. So if I look at my items here, I've got mesh, a cube, a cone, etc., sphere, and that's just been changed there. Alongside that, I've got a float value, which is item value, again, instance editable with the eye shown in this checkbox here. So that means that I can have as many of these objects in the world, set the particular mesh and give it an item value here. So you can see that it's different: 10, 40, 30, 5. This is representing my player. I've just created trigger actor. It could be a first person player, it could be a third person player, whatever, basically. So when you press play, every time an item is collected, it's changing the post-process blend weight so that by the time all the items are collected, the world is in color. Okay. Now you'll note in the top left-hand corner a few things. I've just put some totals in. So the collective value of all those items is 85. So that becomes our total. And then every time I overlap an object, it gets destroyed. But I am then adding a current subtotal. So that first subtotal was 5. That then goes up to 35. And you'll note there's another value here, which is in blue, which is taking the subtotal and remapping it to alpha. So we know our total is 85. Our subtotal is now 85. So we were remapping those values using map range clamped node to change our values to remap it to alpha 0 to 1 so that it controls our blend weight. Now, the beauty of this system is that it calculates no matter how many objects you have in the world. The guy that I was chatting to was kind of locking himself into a system which wasn't particularly flexible. But now we know that our total is 340. And I don't really need to know what the incremental values are, because I know by the time I get to the final actor, so you can see we're at 0.25, which is a quarter, which is fine because we've deleted 3 rows of the same. And when I now go to and select this object, it will be 0, 0 on the blue print string. 0, 0 subtotal remap to alpha. So the moral of the story is, whenever you're building a system, don't make it finite. Make it dynamic so that it can work for any number of objects and values. That then frees you up to basically be creative in the way that you configure a game. You know, you might build something around 15 objects, which was the case in the conversation I was having. But if then in the design of the game you suddenly think, oh, I actually need 17 objects, he was hard coding all the values, whereas here I don't really need to know what the values are. I just need to know what the total is and then work out a kind of proportionate amount based on how much of the blend I want to change. Now let's look at this in a little bit more detail. So we've gone through the item template. We have our static mesh attributed, and we have a couple of things going on. So in my world, I do have this setup item. This is kind of doing all the calculating. And we'll come to that in a moment. That is just a blank actor, which has got some blueprint scripting, and I've just called it item setup. Sorry, there's a police siren going on. You can ignore that. So this just holds a custom event called transition trigger by value. And that will make sense in a moment, as well as a reference to our post process, which is just the post process volume in the world. And then this is my calculation. We'll come into that in a second. I'm getting ahead of myself slightly. So let's look at the item, because that's kind of where the variable is. I've just got a static mesh and a box collision. Okay. As I've mentioned in here, construct script, set static mesh. That's the component. That then is the mesh that I want to select. I've not determined that here because I've clicked instance editable. Sorry, I'm repeating myself a little bit, but just for clarity, we're all at different stages of learning, so bear with me. We've then also got a float. Now ignore the array for the moment, I'll show you that in a minute. We've also got float again, instance editable, and as I've mentioned, we can come in here and I can change these values here and say, all right, actually I want that to be worth 100. Doesn't matter. Because these are all item template, even though we can vary their values and the static mesh attributed to them, when we are calling our get all actors of class item template, we can plug in what's returned into a for each loop, access the item value, and because this for each loop runs for however many of those actors are in the world, we're in effect taking each item value that we put in here in editor, and we are adding it to the total. So that runs all the way through. We've got 16 actors in the world now, so that will run 16 times, taking each and then assimilating that with the total value. So then by the end, when we've completed, that's the print string that I'm printing, which says actor total values. Okay, so that is great. That's just happening on begin play. I've just promoted the post process volume to a variable here so I can access it down here. A bit more straightforward when I access the blend way. Now, this is where things get interesting. If we come to our item template, as mentioned, first things first, I'm getting a reference to that item setup and just saving that as a local variable. Get active class, item setup, promote to variable, item setup. Okay, that just means I can reference it here more straightforwardly. Now on my box collision, I have got other actor, cast to trigger actor. As mentioned, my trigger actor is just a sphere. The reason I'm casting to it, the reason I'm casting to it is just to qualify that that's the actor that is in the collision box. This could be your player, first person player, third person player, depending on what your player actor is. I'm just using another actor for now. But the important point is that we are then accessing our item setup and triggering our custom event. But as well as triggering our custom event on item setup, we are passing through the item value from this instance and then destroying the actor. That's all that's in there. Okay. Now, one thing, if you don't know, when you set up a custom event, you can pass through variables if you just drag and drop that on. Now that item value can be accessed. If I come to custom event 0, for example, let's just demonstrate that. Oh, maybe I have to compile that first, sorry. If I now go custom event 0, you can see their item value, which means I can pass it through. And that's exactly what we're doing here. So every time we're overlapping each of these instances, the value that's held here is being passed through, and we're tallying a subtotal. Get rid of that before I forget. Subtotal. So we're passing that through, we're adding it to the previous subtotal, resetting the subtotal so that's updated, and that's just a print string. Now this is where we are using the map range clamped node. So our blend weight is from a range from 1 to 0. We know our total because we've worked that out, and we're working from 0 to our total. But our subtotal is the value that we're wanting to remap. So because we know the in range and the out range, this node does the heavy lifting for us and calculates if, for example, in range and our total was 100, if subtotal was 50, basically our out range would then equate to 0.5. It's taking where the value is in that range and remapping it to this new range. And by doing so, we can then just put that into our blend weight, and we know, irrespective of what the total and the subtotal is, it will always be remapped to 1 to 0. So in the example that the chap was talking about, again, he was quite finite. I was saying, well, look, if you develop a system that is more flexible, you know, in a game scenario, in one level, you might have 15 objects. In another level, you might have 10,000 objects. This system will work for all of it, for both scenarios. That's basically the thinking and the way that you need to approach your blueprinting. Try and avoid locking yourself into finite values. This gives you much more flexibility and is better practice. So it's good to get in the habit of working this way. You know, by example, well, I've given you an example. We had 4 and then 16, and it did exactly the same thing. But we can be, for the hell of it, we can do way more, and it will just work. If I can find the marker, where's my marker? Here it is. So now if I just zip across and I'm deleting, so you can see the post-process is blending, and when I go to the last one, the blue will go to 0. Bing, 0. And there we are, our total was 1,305. So that dealt with his problem. I just want to extend this slightly so that there's another couple of examples. In this version, I have just tweaked the construction script of the item template. So for example here, if I select those actors, you'll see that now when I'm moving them along, those static mesh are randomly selecting out of an array. So again, just to sort of demonstrate that some of this stuff can be sort of generative, you're not having to prescribe everything. So I have done something here in the construction script where I have got a static mesh array, which I have put 3 elements into, just a cube, a cone and a sphere. Okay, so on the construction script I am getting from that array, and I've just put a random integer in range from 0 to 2, so that's kind of 3 slots. Apologies. And I'm just attributing a value to each of those. So knowing that my first one is a cube, cone, sphere, I've just put 3 values using a select node. So if it's a cube, its value is 10. If it is a cone, its value is 5. And if it is a sphere, the value I've attributed it is 20. So, you know, that might be on this level. On a later level, the values might go up. But again, that doesn't matter. I can promote these to variables and not have them hard-coded. And then I can just update those 3 values, and the maths will still work for calculating the total, the subtotal, and the remapping. So, for example, we're now using these values, and you'll note that my item value is not instance editable anymore because I am wanting to attribute a value per each of the elements within my array. So that's just a sort of another way of handling it. It's just an alternative structure that I just wanted to show. So, you know, fine, that does that. Let's zoom out a bit. Let's duplicate that again just to illustrate the point. If I press play, and I'll just sort of randomly delete these, and then the last one, boom, 0, 0. Same thing, okay? Now, you will have noted that this is using a post-process volume that is in the world. Okay. Now, one thing that you can do, let's just look at my item setup. Because there's only one process in the world, I'm getting get actor of class and setting PP. Now, as a little trick, what you can do, if, for example, you want to transition between two very stylized looks, you can certainly do that too. And you can still use this method, but what I would recommend you do is, let's have a look. So you'll now know I've got two post-process volumes. Both of them are enabled and on infinite extent, but one of them is the grayscale, as you can see, and if you recall, I only had one get actor of class, so it will get the first one, basically. We'll look at how we can get them individually, but I'm only accessing the first post-process volume. What I've also done is set the priority. So for example, here you can see it's priority 1, so that gets rendered to screen in favor of that. Let me just check that a second. Yeah, because if I change that to 1, we're now getting the color and the grayscale isn't being prioritized. So let me put that back to 0. I want the grayscale first, and we are incrementally removing, not incrementally, we are remapping that value and deducting that from 1 so that we are fading out the blend weight to reveal the second volume. So rather than setting or swapping out values in a single post-process volume, you can have a couple and then just blend from one to the other by setting the priority. So here, for example, we're grayscale, excuse the flickering. Oh, flickering, it's just a sort of crude. But there we are. We're now, in a similar way, we've gone back to 0. So now that has gone from one post-process volume to the second, and it's additive. So although it's grayscale, it has kept the kind of grading of the shadow detail, and then just as a priority being number 1, set everything to grayscale because we've desaturated the global value in that post-process. So that's all that's happened there. So it's a way of blending between two styles, but it is additive. So it will be, it might not necessarily give you the effects that you necessarily want, but in terms of trial and error, you can experiment with that. And as a final little test, really, and just to relay to you, rather than the post-process volumes being additive, what I have done now is basically blending from one to the other. How have I done that? So in our item setup, you can see that I am doing a get all actors of class and then just promoting that to variable. So I've got post-process volumes, plural. We can ignore that total, that's exactly the same, but this is where I've changed things up. So you'll note that our map range clamped here, this one, which deals with post-process volume 0, our first one, black and white, is remapping our values from 1 to 0. So we are going from fully enabled blend weight 1 down to 0. So we're fading that one out. But this one, the range is the other way around, 0 to 1, and we are getting post-process volume 1, which is our second one, and therefore we are fading this one up. So coming back to our example, you can see we've got grayscale, we don't have that dark shadow at the top, which we had when it was additive. But now when I'm going through, you can see that it's becoming color. It's going into the second post-process, and now it's getting darker and more saturated. So we've got two distinct styles that we're going one to the other without it being additive. Anyway, I hope that's of use. Many thanks. So I hope that video is of use. If so, please do like and subscribe and hit the notification bell to receive any updates. And thank you for your support.